Hey, Algebra 1. Okay, so in today's lesson, we learned how to use the IQR, the box part of a box plot, all right, that box part, in order to find and determine whether something is an outlier or not. Okay, so let's dive into the actual lesson itself. Um, yeah, so this is like just a little visual, uh, of like, hey, outliers are really far away from it. If we use 1.5 times the IQR, above or below Q1 or Q3, then it's an outlier. Okay, so it says right here, Ricardo got the following scores on 5 assignments. Okay, so we got these scores plus that 100. His teacher lets students decide whether their final score will be their mean or the median of those. Which so the teacher's not letting you drop a score, drop that 0, but which one would give Ricardo the higher score? Well, that 0, that's going to pull the mean, the average, down. This was like a lesson from before. But the median, the middle value, would stay the same. The middle value looks like a 90. So Ricardo will get a 90 if we leave it at the median. Okay, because the mean gets pulled down by outliers. Okay, number 3. This histogram represents the number of text messages that 20 people receive in one day. How many people received 15 or more texts in a day? So again, this is the number of texts. These are the number of people. So we want 15 or more. So when we look at this, it means I can take all of these and take the heights of this one and this one and this one. All of those would be 15 or more and add them up. So we get, let's see, 9 plus 2 plus 1, so that's 12 people. All right, let's move on. All right, so problem number 4, same one, but if you added a person who received 52 texts, so all the way over here, 52 texts, would the mean or the median change? Well, here's the thing, is that which one would change more? Because I was going to say, because we're adding a person, the median could change. All right, so it looks like the middle is going to be here, but it might be enough to move the median just a little bit more. But the mean will definitely move more. Averages change more with outliers. Okay, and let's go back to that. All right, move on. Number 5. All right, oh, great. So we got a data set. All right, so Julian says that 37, that number 37 there, is an outlier because it's the maximum value. What would you say? Well, I'd say let's graph it. And if we took this list and set it equal to that list, 9 elements. Next one we said box plot of L. Okay, and it says exclude outliers. I'm not going to take that off, but let's see where this box plot is. Okay, so the box plot's over here, and as I zoom out, 37 is right here at the end. And look at that box. The box itself is the box itself, if we took that box, took that distance, stretch it out here, that end is within one use of that box. Never mind the 1.5 threshold we saw in class that determines whether something's an outlier. So it's, what would you say to help him understand his mistake? I would explain the whole IQR thing. Here we go. This dot plot that represents the ages of different people in a bike shop. Which data point would be an outlier if it were added to this? So we want to look for something that's vastly different. 8's kind of close to this. 44, okay, so 8 is only 4 units away from the lowest value of 12. I don't think 8 would be. 44 is 4 plus 10 more units, 14. It seems like 44 would be the answer. Yeah, textbook says, it's 44. All right, but not both. Problem number 7, dot plot represents the data from A. Select one point to remove from the box plot so that it would be box B. This is interesting. So here's the thing. When I look at this, they're just asking us to remove a point select one point to remove from the dot plot. Okay. Oh, start over. Interesting. It's not like dynamic. It doesn't like, That's it. It's just, okay, interesting. Sorry, you're watching me like, just kind of like look at this one. So right now, A doesn't say that this point over here is an outlier. All right, and that must be because the box itself is just slightly edged up this way. So if I want the box to get slightly edged out this way, it seems like if I removed a point that was close to this one, like if I remove this point right here, it's not even, there we go. If I remove that point, then I've just lost a data point that is here. So this box likely would get pulled down. So I think as long as I took away any of the points that are kind of up in this range, close to that point, yeah, then it should bump that box down, make it a little further away from that point. And now that point ends up being an outlier. Okay, easy enough. Hey folks, take care. Hope that made sense. Yeah, bye.